So there are few errors, but you can find out what those errors are by yourself. Yeah, quite obvious. There was a question where both had given a wrong answer. I don't know why you gave that answer. Question number 8. A quiz has 25 multiple choice questions. Each question has 5 possible answers, one of which is correct. A correct answer is worth of 4 points, but a point is taken off for each incorrect answer. The student answers all the questions by guessing at random. The score will be like the sum of how many draws? You both say 0 draws. What was the reason saying 0 rows? Or did you probably didn't understand the question, right?
No, there were 5 answers now, so the average was 0, that's it.
No, here we want to look at the total marks, no? The
Yeah.
student, the score will be, what is, in order to get the score, now you have to draw actually 25 numbers with replacement from this box, right? Where one number is 4, the other numbers are negative ones, right? So once you get, for example, 1, you get 4 or a minus 1. If your answer is correct, you have 4 marks. If wrong, minus 1. Then you have to draw another one, right? So then that is correct. Again you get 4, otherwise minus 1. So sum of those 25 draws will be equal to the total marks. So therefore the total score will be like the sum of 25 draws from this particular box, where the box has 4 and 3 negative ones. 25 draws, not 0 draws.
4 negative answers.
Huh?
There are
Oh, five answers, yeah, 4 negative ones, yeah. So the total number of draws should be 25 for each question is like a draw. So that was the only question that I had, why you made that mistake. Both have made the same mistake. So probably the question was not very clear. And the other one was about the position of the, well, not the, yeah, the mean. Right? Both had the same answer again. When you have symmetric distribution, usually the mean is in the middle. When the distribution is positively skewed, the mean is towards the right side. Right? So the mean will be the larger value in that case. Right? For example, there I think the middle value is 50, the larger value is 60, and the smaller value is 40. So when the distribution is left skewed, mean should be 40. Right? When the distribution is right skewed, mean should be 60. You had the other way around. That's another mistake. Okay, so the other ones you can easily find out the errors. So today we are starting a new section in the book. It says sample surveys. So in this section we will talk about some surveys, sampling methods actually, basically sampling methods, how to select a sample, and some problems in some type of sample, some sort. And then we will go to we will estimate or forecast certain things using surveys. Right? When you forecast or estimate something, there is always a possibility of error, and then we will look at how to estimate the size of the error. So first of all, we need few words here. These are well-known words. Right? So always we want to study about some kind of population. Right? So the population is a well-defined set of entities, items, so people, about which we want to make some conclusions. Right? So it's a group, usually a large group. That is a group about which we want to make some conclusions. Now, if you want to make conclusions about this thing, one thing you could do in some cases is to get the data from each and every item in the population. But because usually the populations are large, this is not very practical in most kind of situations. We need a lot of money to collect data, a lot of time, a lot of people to collect data, and so on. There are a lot of restrictions. Therefore, usually we don't do that. We don't. There are, for example, censuses. And if you collect the data from the whole population, that is called a census generally. Census and census department does it every 5 years or so for Sri Lanka whole. So they collect data from every household. But that is not done every day. Right? So usually what we do is take a subset, which is called the sample from the population, and then get the data from that subset, and then based on that data obtained from the sample, we make some kind of guesses about the population. Right? So those guesses, we use some scientific methods to make those guesses. So those are called statistical inference. We make inference, statistical inference about population based on sample. So when we say we are interested in some properties of population, they are usually we are interested in some constants related to a population. For example, if maybe we are interested in a mean, population mean, right? What is the mean income of people in a certain area? So there's a population. It might be a population proportion. What is the proportion of people in the population who will be voting for a certain candidate? Right? So that's again a population proportion. Right? Or we might be interested in finding out the correlation coefficient between two variables for the people in a certain population again. Right? So these are usually constants. Right? We may be interested in one constant or several constants in the same study, but they are constants which are unknown, right? That's why we want to find out them. If we knew them, we don't have to do any study, right? So they are unknown constants. They are called parameters. In statistics, we use the word parameter. In other disciplines, the same word is used for some other meanings, but in statistics, usually when you say parameter, it is an unknown constant, usually related to a population. Right. So, as I said, what we do is we collect the data from a subset of this, that is from a sample, and based on that sample, we calculate a quantity, and that quantity is usually called a statistic. A number that we get using the data. It's called a statistic, and we usually use these statistics as guesses, scientific guesses for the population quantities. We call them estimates or forecasts, predictions, and so on. Right? So the four words are population, sample, parameter, and statistic. Parameter is related to a population; it's an unknown constant. Statistic is coming from the data. So parameters are the quantities that we want to know. Statistics are what we investigators actually find out, actually observe using the data, actually compute from the sample. For example, a famous survey, certain company wanted to find out the true proportion of people who will be voting for Roosevelt versus I think London or somebody in a certain election in America. Right? So in that case, they are interested in the population proportion of people who are will be voting. So that is the parameter. But of course, we cannot ask everybody who you are going to vote for. Therefore, they have to collect a sample, and based on that, they got some estimates and then they forecast. We will talk about this particular study in a minute. Two type of people, two different people, companies did the study. One made a big mistake, the other got the correct answer. So we will look at what they did, what are the problems. So the key idea is statistics are used to make statistical inference about population parameters. So this when you estimate or make inference about a population based on the sample, one important thing is that the sample should be a good representative sample of the population. Right? That means sample should reflect almost all the important characteristics related to what we are going to study. That is the same as in the population. Right? If, for example, the characteristics, suppose for example, we are going to study about the say weights of people. Right. So somebody is interested in the mean weight. Right. So usually we know that men have more weight than women. Right. So if your sample has a lot of men than females, so you will get a wrong answer. The sample is not a representative. So if the population has about say 48% men and 52% women, sample should have roughly the same proportion. Otherwise, it's not a representative one. Right? So in that case, the estimates will not be good. So that's why we say they are not working well. But if the study to work well, the sample has to be a representative one. But the problem is once you have a sample, usually there is no way for us to know whether this sample is a representative one or not. Right? Why? For example, if you take the same previous example, in most cases we might not know the actual composition of the population, right? For example, now usually we know men and women composition, but some other proportions in the population we may not know actually. So therefore we don't know how to check whether that proportion is the same as in the sample. To check whether it's representative. So that is a problem. Right? So therefore, we cannot check whether a sample is a representative one by looking at the composition of the sample because we don't know the composition of the population also. Therefore, we cannot mesh them. Right? So what we do is, therefore, instead of that, we use some standard accepted sampling methods where theoretically they have shown that those sampling methods usually give representative samples. Right? Theoretically, people have shown that these methods work well and these are giving you representative samples and so on. So that is the thing. Instead of by looking at the sample itself and then comparing it with the composition of the sample with the composition of the population, which is impossible to do usually. We select suitable sampling method and then according to theory, we know that it's going to be a representative sample. So that's what it says. Since we cannot inspect the population directly, the method of sampling must be examined. The method of sampling that we have to be careful about. So there are so many methods. Mainly there are we can divide them into two categories. One category is called random sampling methods. Or they are also called probability sampling methods. Random sampling or probability sampling. The other set is called non-random sampling or non-probability sampling methods. Right. So some of these non-probability sampling methods usually give something called biased results. But usually the random sampling methods are well accepted. They usually provide you representative samples and therefore the results will be usually unbiased. Right? So therefore general recommendation that any statistician can give is whenever possible use a random sampling method to collect data. Right? There are situations where practically it is not very easy to use random sampling methods. In that case people use non-random sampling methods also. Right? But in that case you have to be careful when you interpret the results. Usually there can be a large bias in the result and so on. We will come to that. those methods a little later. Right? So non-random sampling methods usually have this problem of biased results, but if you use randomization, random methods, usually we can avoid that problem. Now I will just talk about one or two examples, previous well-known examples where people have uh, uh, done some predictions about the elections, and some studies have got completely wrong predictions, and why we'll study why they were wrong, some reasons. Right? So one famous study was this election between Roosevelt and, I think it's called Randall, yeah, Alfred Randall. Right? So the Roosevelt was actually already the president. He was campaigning for the second term, right? So he had already done some work, and people knew what his this thing was, right? But the Landon was the first time contended. So he was a Republican. The Roosevelt was Democrat. So at this time, actually, what you call Great Depression was still there. There were a lot of problems. Unemployment rate was very high. People had less income and so on. A lot of problems in the country. Therefore, actually, Roosevelt had already suggested or started a new program called New Deal, where they were spending a lot of money to support these poor people. Right? But the argument given by the other people was government was spending too much on these people, and therefore we should not do that, and so on. So there were two different views from these two people. So anyway, the election was to be held in few days. Some people were interested in forecasting who is going to win. So at the time, actually, in this time people didn't know much about the scientific sampling methods. Many people were believing that if you can get a larger sample, then your result will be more accurate. That was one belief. If the sample is very, very large, then the result will be very accurate. That was one belief in that time. And also the main method people used at this time was mailing, sending mail questionnaires, right? Mailing questionnaires and getting responses back. So this one company called Literacy Digest, it's a magazine. So this magazine actually used to hold this kind of surveys large number of times before, and they had actually predicted quite well in those surveys. But this time actually something went wrong, right? So they actually, what they did was they did a very large scale mail survey study. About several millions of mails were sent, questionnaires were sent by mail. So they believe that if the large number of responses received, then the result will be accurate. Until this time, actually, until this poll, their predictions were pretty good, and therefore they were actually very prestigious. Many people were believing in their predictions. This time they sent about 10 million questions, so this is where they made some problem actually. When you want to send email questionnaires, you have to have addresses, no? Right? You have to have addresses. So they got these addresses from several lists, available lists. For example, telephone directories, right? Automobile registration lists, magazine subscription lists. They are magazine itself, right? And then some other club and association memberships. Right, so they had this kind of lists with addresses, so they got those lists and send the questionnaires to everybody in those lists. Right. But even though they sent 10 million questionnaires, the response rate was very low. They received only 2.4 million responses out of 10 million. So by this time, because of this, Roosevelt has already introduced a new social program. Many people actually favored him, right? Many general people believe that Roosevelt will win. But of course, according to this particular survey, Literacy Digest forecast was the other person will win, right? So Literacy Digest forecasted that Roosevelt will receive 43% votes and the other will receive much more than that. Therefore, their prediction was that Landon will win. However, the actual result was Roosevelt won with a landslide, very, very high percentage, 62 Roosevelt and 38% to Landon. Right. So this time, therefore, somehow their forecast was completely wrong. Completely wrong. Not a very small margin, by a very big margin, the prediction was wrong. So we will little later discuss why this was wrong. But at the same time, there was another company started by something called George Gallup, person's name. He was actually introducing new scientific sampling methods. Right? These people, the other people were just using male questionnaires most of the times, but this person was now introducing. He has just started a polling organization, his own company, and his methods was scientific. He was proposing some random sampling methods. Right? So in order to show that these random sampling methods are better than the previous methods, actually he also conducted two surveys. He conducted one survey to predict literacy surveys prediction before them, right? He conducted that survey to predict literacy surveys prediction before they predict it, and then he also did another one to find out the actual the person who will win the actual election. So in both methods, he used some random sampling methods. So in the first one, he used only 3,000 people to predict the digest, not the Reader's Digest, as a literacy digest prediction. Right? So he wanted to predict what literacy digest prediction will be before they predict it. Right? So for that he used only 3,000 people, but he knew how the literacy digest was going to get the addresses. He knew that these people were going to get addresses from different lists. So Gallup also used the same list to get the addresses. So he also used male questionnaires, but he got the addresses using a random sampling method. The other people sent questionnaires to all in the list, 10 million, right? So this person sent only to 3,000 people, but the selection was random sampling. So because of this random sampling, his 3,000 sample was very representative of those lists, right? It's like a population almost, right? So it was very representative. So using that, he predicted literacy's prediction, and it was actually correct, very close to the literacy's prediction, right? So predict. So he got the similar to Literacy Digest magazine. He got his list also from the same list, but he used the random sampling method. So, but he used in this case only 3,000 addresses, right? So he predicted what digest predictions would be going to be well in advance in this the prediction. Gallup's forecast for the digest prediction was 55%, right? So he predicted that digest would say Landon will win with 55% votes. But actually, Digest prediction was not 55 but 57. So there's a very small difference. But the prediction was correct because Digest was going to predict that the London will win. According to this, Gallup was also saying that these people will be saying London will win with this. So he was pretty accurate. So that shows actually one thing, that is we can predict whatever quantity we want. In this case, the quantity that you wanted to predict was the prediction that would be from the Digest one. We don't need that many large samples, only 3,000 here, right? And but the sampling method is important. It has to be a representative one, right? Representative. So that is one lesson that we can obtain. So Gallup therefore correctly predicted the Digest incorrect forecast. If you look at the other one, 50,000 people prediction, that is to predict the actual outcome of the election. There also he used sampling methods. Actually, that is, he used something called stratified random sampling. We will talk about a little bit more about this thing a little later. Stratified random sampling, where he first of all stratified or divided the whole population into different, something called strata, sections, right? Depending on some variables on which the vote will depend, right? So, for example, young people may be mainly voting for one person, the older people will be voting for some other people. If the voting pattern will depend on the age, then we divide the population according to the age group, for example. Or if you think that certain areas, people, this area is more going to be this for this person, this area is going to be more people, more for the other people. So that means the voting pattern depends on the area also. So if you think that that is case, then you divide the population according to the area also, right? So like that, depending on which variables the voting pattern depends, they considered several variables, and then they considered combinations of these variables. For example, area A, and within area A, then several age groups, right? And then each of those simple small groups, from each group they took a random sample. So therefore, each possible group is represented, right? So that's what you call the stratified random sample. So using that method, he was able to predict accurately the actual winner. He actually predicted, the Gallup actually predicted that Roosevelt will win, right? And his the number, the actual proportion was little off from the actual value, but he was anyway able to at least predict the actual winner, right? Whereas the more famous, up to now prestigious Literacy Digest was completely wrong. He was predicting London will win, right? So again, therefore, this shows he used only 50,000 instead of 10 million. He used only 50,000 people. And he used some random sampling methods, right? Stratified random sampling method is a random sampling method. It gives you a representative sample, right? So these two show that random sampling methods are much better than non-random sampling method. Actually, what Literacy Digest used was something like a convenience sampling. It's called a convenience sampling. They have just got the list and then sent mail to everybody in the list. So that's called convenience sampling. Right. So Gallup predicted Roosevelt will win with 56% of the votes. Actual percentage for Roosevelt was 62%. So there was a difference of 6% actually. But anyway, still he was able to predict the correct winner, Roosevelt. So what was the problem in the Digest survey, actually it had mainly two problems. One is called the sampling bias, the other one is called the non-response bias. Right. The sampling bias occurs when you select a sample if there is a possibility that some groups of people don't have any chance of being selected. Right. Generally, what you need is in the population, everybody should have some known chance of being selected. Right. Then that is called a random sampling method. Random sampling method, in the random sampling methods, everybody has some chance of being selected. Probably not the equal chance, but some chance, and usually we know what is the chance for these two type of people, what is the chance of being selected, these type of people, what is the chance of selected as known chance. But in some sampling plans, there are some groups of people who don't have any chance of being selected. For example, the method that the literacy digest use, they use those lists, no? So those lists, for example, telephone lists. At those times, telephones, there were telephones only for rich people. Poor people didn't have telephones. So therefore, poor people didn't have any chance of getting a question. Right? So they were completely ignored in the survey. Right? And similarly, automobile lists. Right? Only rich people had automobiles. So therefore, again, poor people were ignored. But on the other hand, poor people were more favoring Roosevelt because they were getting the social benefits and so on. Right? So that was one major problem. The sample was not a representative sample; it was a biased sample, biased against the poor people. Right? So that is called the sampling bias. Sampling bias. And then there was another big thing, that is the non-response. Right? 10 million questionnaires were sent, only 2.4 million received. Right? So what was the reason for that? There are some people who don't care responding, right? They usually also it becomes a nuisance sometimes. But anyway, sometimes these respondents may be a special group. For example, those are the people who are really interested in the election, right? Election or whatever the result. Maybe only rich people are responding, only in this case. Anyway, questionnaires were sent to rich people only, right? So out of those, maybe a particular group only responds, right? So therefore, again, when you get a non-response, we have to think why the non-response can occur, right? If the non-response occur due to some particular reason, that creates a bias. That creates a bias. But on the other hand, if the non-responses occur randomly, that's not a problem. But if the non-responses occurs because of a particular reason, then that creates a non-response bias. So literacy digest survey had both of these problems. Whereas the Gallup's one didn't have these problems usually. There might have been some non-response. Actually, I tried to find out what the non-response rate in that one was. There's no information about that. But there was no sampling bias mainly, right? Because it was a random sampling method. The sample was a representative one. Right. So here it says, for example, those who replied were more politically interested, more fluent. So the questionnaires were sent to fluent people anyway. So out of those, responses were sent by more fluent people, and therefore they were more likely to be voting for Landon. Non-respondents differed sharply from respondents, creating a large non-response bias. When there is a high non-response rate, you have to look out for non-response bias. Right? So you have to think of whether there is a possibility that special reason for this kind of non-response, and therefore creating bias. Right? So on the other hand, Gallup's 50,001 study, they didn't have these problems. So this is an example where at that time Gallup was able to show that scientific methods are much better than the usual existing methods. So that created some kind of awareness among the people about the sampling surveys. And then there is another survey for another election. A Republican person called Thomas Davey challenged the incumbent Democrat Harry Truman. So Harry Truman was already there. So in this case also, three major polling organizations ran national-wide pre-election polls. One was Crossley, the other one was again Gallup, and there's one called Roper. Right. So all these newspapers or magazines, they were having these kind of magazines or newspapers. So the purpose was to predict the winner. Right. Now all these three surveys actually they use something called quota sampling in this case. They all three use quota sampling. This quota sampling is kind of a non-random sampling method. In a quota sampling, what they do is actually they try to select a sample to represent the population. But what they do is, for example, they look at the composition of the population somehow from previous studies. We can do that only if we know that previous composition of the population, right? So age composition, income composition, and whatever the variables they have available. Right? What is the percentage of male, female, what is the income distribution, and so on. They find out all these things, and then they ask the interviewers. They send the people to interview people. They ask the interview, okay, you, for example, select 48 men and 52 females. And out of those 48, this many should be in this group, this many should be in this group, this many should be in this group. They give the numbers. And then like that, and this many should be from this area, this many should be this area, and so on, to match the population percentages. So they assign those things and they send the interviewers to collect the data. But what happens is actually when the interviewers select people with those characteristics, they select whoever the person they want. For example, men, it may be a person, male person with that age, but probably, for example, if that male is looking rich, interviewer might be selecting that person than poor person with the same, right? So therefore, there is some bias, interviewer bias introduced by this, right? Even though we try to match the percentages in the population by giving the numbers, those who are selected by the interviewers according to their wish, right? So therefore, there is some interviewer bias usually, right? For example, what happens in this one was the Devi. Usually rich people were favoring Devi, the poor people were favoring Truman. But when they selected the people using the quota sampling, most of the interviewers selected rich people. They were, because these rich people, one reason was they were willing to talk to these people. Because if somebody doesn't want to talk, we cannot get answers now. So these rich people were more interested in the election. So when you go and ask questions, they were more interested in answering questions. So therefore, most of the respondents were rich people. Right? So therefore, finally, their prediction was that Devi will be winning because most of the respondents were Devi, and those rich people were actually more prone to Devi. Right? So by early autumn, all three polls had declared before the election, Devi is the likely winner. But actually what happened was Truman won. So this was the results that they got. Crossley said Truman will win Truman will get 45% and Devi will get 50%. So by Devi will win and Gallup said Truman will get 44%, Davy will get 50%, and therefore Davy will win. Roper said Truman will get 38%, and Davy will get 53%, and therefore Davy will. So all three predicted that Davy will win. But actually what happened was Truman got 50% and Davy got only 45%. So therefore Truman won. So in this case the main problem was interviewer bias. The sampling, even though quarter sampling is done to represent as much as possible the population, it's not a random sampling method. There is some non-random element in the selection, right? Interviewer bias. So when you have that kind of problem, that again can give you a wrong predictions. Right. So the quarter sampling had two serious problems. That is one reason was actually, now they think that, for example, they look at the quotas according to several variables. For example, gender, maybe the area, maybe the income. So they think that voting pattern will depend on these variables. So thinking that, so population, they try to mimic the percentages in the population for those variables in the sample. But there may be some other factors which they have not understood, which may actually change the voting pattern, depend on the voting pattern. So if you don't consider those variables, then it's not going to be a representative sample from the population for this particular study, right? Maybe some other variables are matching according to the proportions, but some of the important variables have not been considered. So that was one reason, right? And the other one was the interviewer bias. So quota samples can look demographically balanced yet still be politically unrepresentative. So demographically, gender and everything may be okay, balanced, but there may be some other variables which are politically important and which has not been considered. Right. So in quota sampling, at that time actually quota sampling was considered as a very good sampling method. That's why even the Gallup, who was promoting for scientific methods, even used the quota sampling method. But the problem is there can be some unintentional interviewer bias, and therefore it can create completely wrong answers at the end. Right. So both of these studies, the previous one, Roosevelt's election, and this one, Truman's one, these both studies show that non-random sampling methods, right, are not very good, and if possible, whenever possible, use the random sampling methods. If you can do that, then your results are more valid or more reliable than the results obtained from the non-random sampling methods. So these random sampling methods are called probability sampling methods. I think just mentioned, yes. I have just mentioned, these are not in the books, but I just added them. There are several random sampling methods. These are the building blocks, right? Several different types of. So one random sampling method is called simple random sampling. Another one is called the stratified random sampling. That is the method that was used by Gallup for the Roosevelt polling. And then systematic sampling and cluster sampling. They all are random sampling methods, and they theoretically promise representative samples from the population. Right? So just to explain very briefly each of these, simple random sampling is the most simple method. Of course, practically it is not simple, but the idea is simple. This is the sampling methods where each and every person in the population has equal chance. Right? We select a sample so that everybody in the population has equal chance of being selected. Chance has to be equal. So this is usually done using a lottery method, right? One thing is that in order to select a simple random sample, we need the list, all list of all the individuals or people in the population, right? So that is called a sampling frame, right? So we need the sampling frame, right? We select the sample using the sampling frame. So for example, it may have household numbers or people's names, whatever. So we can feed this into a computer and then ask the computer. Nowadays, earlier days they were using several other methods like random sampling tables, random number tables and so on. But nowadays we can use a computer to select a simple random sample. Only thing is that we have to have the complete list in the population. Right? So that is a practical problem in most. There are a lot of situations where we don't have a complete list for the population. Right? So when you have that kind of problem, we'll have to use go for some other random sampling method like a systematic sampling. I will come to that. So when you take a random simple random sample, of course, most of the times it gives you a representative sample, but there is a very small chance that some samples may not be actually representative. For example, if you say select 50 people out of the 1,000 people, right? Suppose in the population of 1,000 people, there are 52% female and 42% males. Right? So when you suppose you have the list of all these 1,000 people, and so you feed it to a computer and ask the computer to give you 50 people out of that. Right? It is possible that in the sample there may be less female than males. There is a small chance of happening that. So if that happens, then the sample is not really representative. In the population there are more females, but in the sample there are more males. Right? So that can happen with a small chance. So if you are really if you really think that gender is important to your answer, then you have to be careful that at least the gender representation should be correct in the sample also, like the sample population. Right? So in that case, what we can do is we can take samples from each gender separately. Right? So in that case, we can say, okay, we can in the sample we get 50. So 48 out of 48% of 50 we get from the male subgroup, and the 52% of the 50 we get from the female subgroup. So that is called the stratified random sampling. We divide the population first of all into two strata, right? Male strata, stratum, singular word is stratum, plural word is strata. So we take a simple random sample from the male stratum, whatever the proportion we want. So and from also we get a simple random sample from the female stratum. In that case, we will have the same proportion as the population and from male and female. So that is called the stratified random sample. Right? So in that case, we have to divide the population into different categories, different groups, depending on some variables which are important in predicting or getting the estimation. Right? So, for example, when you are predicting something election, if you think that males will be more prone to one group and females will be more prone to the other group, so then gender is an important factor in voting. So, in that case, probably stratified random sampling will be better than simple random sampling. So, in both cases, actually, we need the list, right? In the simple random sampling, we need the list of all the people in the whole population. In the stratified random sampling, we need the list separately from each group. Males, we have to have a list. Females, we have to have a list. So that's going to be a problem in most of the situations where there are lots of situations where lists are not available. So in that kind of situations, one thing we can apply is systematic sampling. Systematic sampling can be done even if you have a list, but it is more useful when you don't have a list. For example, suppose you want to get a sample of customers who are coming to a certain supermarket, right? You want to estimate certain quantities related to that supermarket, right? So you don't have a list. There is no list of customers who are coming to that supermarket, right? To take a simple random sample or a stratified random sample, right? But you may have some idea about how many customers, right? Like 10,000 customers. They have, for example, this Nexus numbers and so on. From that, they have a general idea how many customers, right? So, for example, if they think about the 10,000 customers are there, then if they want to take 50 people out of that, what they can do is maybe they will select several days of the week, and then every day, for example, okay, first day they will select 10 people, another day 10 people, and like that. But how they do is that so if there are 10,000 customers, you divide the 10,000 by 50, so then you will get 200, right? 200. So you have to get 1 in 200, 1 in 200 people to get 50 people out of this 10,000. So usually what we do is we first of all select randomly a number between 1 and 200. Randomly. So there we select the number randomly between 1 and 200. Say for example you got 75 as your number. So then you get the you'll have to be observing the customers when they are coming to the supermarket. So 75th person will be your first person selected as a sample. And then after 200, right, 275th person will be the second person that you will be selecting. Right? Like that you will be doing until you get 50 people. So that's called the systematic sample. So there you don't need a sampling frame or the list, but you have some idea about the number of customers, the number of people in the population. Right? So that again gives you a random sample, because the person who is going to come as the 75th person, we don't have any control of that. No. The interviewer doesn't have any control, so it's completely random. Right? And then the last one is cluster sampling. Cluster sampling is somewhat similar to stratified random sampling because it also divides population into several groups. But in the stratified random sampling, we divide the population into groups called strata, where the strata are similar. Within a strata, they are similar. For example, they all are males, the others are all females, for example. So they we call the strata are homogeneous within homogeneous, but between strata they are different, males and females. So within strata homogeneous, between strata they are we call heterogeneous. In the cluster sampling, what we do is actually we use the cluster sampling when there is a very large population, if we can divide the population into some subgroups where each subgroup is very similar to the whole population, right? If you can do that, right? Each subgroup is very similar to the whole population. So if you can do that, for example, there is a population, there we can divide the population into several. Usually this is based on geographical variables and so on, geography. For example, certain area and then certain province, for example. Right? If certain province is very similar to the whole Sri Lanka, it's not going to be Sri Lanka. Sri Lanka is quite different, but there are some other countries maybe or some other situations where so this subsection is like all the population. This subsection is also similar to the whole population. So in that case, instead of selecting people or items from the whole population, which may be very large, what we can do is we can randomly select few clusters. These are called clusters. Right? So once you select one cluster, it is like whole population. Right? So it's representing the whole population. Right? So maybe selecting 1 or 2 clusters only. So therefore it's easier. Otherwise, if you, for example, like in America, if you select a random, simple random sample or stratified random sample, they may come from the whole America, where these people are from various different places, which are very different distance, right? Very big distance between them, right? So if you, for example, have to go to collect data, it will be very, very costly and so. In that kind of situations, if you can just select one, say, county, or 2 counties, and then go to that county, and within that county you can collect the data with a smaller cost. So that kind of situations, again, that's called cluster sampling. That's again a random sampling method. So these are actually the 4 basic random sampling methods. But actually in large scale studies, what people do is they combine these. They don't use only one. They combine these and they use something called multi-stage random sampling, multi-stage cluster sampling and so on. Right? So for example, even in Sri Lanka we do these kind of things. For example, if you go to collect some people into a sample to get some idea, for example, say they want to get some idea about garbage collection, say, right, in a certain area. So they want to get their responses about whether this service is good and what else is required and so on. What we can do is, for example, first of all, if it's a large area, we can, for example, divide that area into several gram sevak areas, so that each gram sevak area might be considered as a cluster, for example, right? And then select several clusters, 1 or 2 clusters, instead of taking sample from the whole area. So once you have this cluster, you can get maybe probably a map of that area, right? And then you can find out rows, right? So roads, you can select several roads randomly, right? You can give names to the roads and then feed into the computer and select some roads randomly. And then within a road, probably you can use systematic sampling, right? If you know how many houses in that road and so on, roughly, you can select systematic sampling and then go to those houses and get the data. So like that, multi-stage sampling is the more practical one, but that is again can be considered as a random sampling method. On the other hand, these methods are not that easy to implement all the situations, because some need lists. Sometimes we don't know how many in the population, and systematic sampling is also not possible. So there are lots of situations like that. Therefore, people use non-random sampling methods also. But in that case, of course, we have to be careful about our answers. So these are some non-random sampling methods. Convenience sampling, just based on our convenience, right? So, for example, if there is a big class, if I want to select 10 people, I will just select people in the first 2 rows. So that's a convenience sample, right? So those who are willing to sit in the first row will be only selected. So there are some people who never come to the first row, they will not be selected at all. But that is a convenience sample. Right? A judgment of purposive sampling is another one. That is actually they are trying to select a representative sample, but according to the judgment of some expert, right? According to what he thinks as a representative sample. Right, so we ask some expert in order to represent the population, what percentages should we take and so on. So he will tell some according to his knowledge, and then we try to mimic that in the sample. But that is not going to be the same as some other person's statement, right? So therefore, there is a subjective view into that. It's not going to be random, right? But that is called the judgment sample. Quarter sampling I mentioned again. They are usually based on well-known percentages in the population, right, in different variables, and then we try to we instruct the interviewers, go and collect this many people from male and female, and then within male this age group and so on. Numbers are given, but of course then the people who are going to be selected is based on the personal preference. There are situations where sometimes we cannot reach each person. For example, if you want to collect some data on drug addicts, for example, it's very dangerous to go and find out all the drug addicts. One thing we can do is maybe find out 1 or 2, catch them, and then get the information from them, and then okay, maybe contact drug addicts. They trust each other, no? So they introduce to some other person and get the data from them, and so that kind of things. The other one is actually volunteers, right? You ask, for example, publish that we want to do a study, volunteers are accepted. So the volunteers again can be a particular group that's going to be very biased sometimes, right? But anyway, that is also done, self-selection. So those are non-random sampling methods, but the main thing is that whenever we get some estimate or prediction, usually we are interested in saying how accurate this prediction or estimate would be, right? In other words, what would be the likely error in our estimate? That's an important thing to ask. Now the main important thing is that if you use a random sampling method, we can get some value for the likely value of the error. That is very important. But in any of these non-random sampling methods, it's impossible. You can get an estimate or prediction, but we never know what the likely size of the error in our prediction. So that's a big problem. Right? So that is the main problem actually. There is always a possibility of error due to non-response and interviewer bias and selection bias and so on. But we will never know what the accuracy is. So there's a big problem there. So that's why we always say, whenever possible, use a random sampling method to select the sample. Right. So why do we need several random sampling methods? Why can't we use a simple random sampling method always? As I mentioned, simple random sampling, one thing is there is a small probability that in simple random sampling that the sample itself may not be representative. Right? There's a small chance. So if being representative is very important for a particular result, then of course we have to look for example, stratified random sampling and so. The other thing is, it may be very costly, right? Even if one main problem is sometimes we don't have lists, so in that case we cannot do a random sampling method. It can be very costly, right? If you select, say, 1,000 people from the whole America, these may be from all the corners, then we'll have to go to them and then collect the data, so it's going to be very costly, right? So that's why nationwide simple random sampling method is not suitable. So that therefore, as I mentioned earlier, people usually use the collection of or combination of random sampling methods called multi-stage sampling, mainly multi-stage cluster sampling. So for example, population is divided into say several provinces. Then out of, if you can think that this method will be working only, for example, if you can assume that each cluster is very similar to the whole population, otherwise again there can be errors. Right, so you will select few clusters and then within clusters maybe using some other methods, few areas or few subsections, and within that again like roads and so on, several methods can be combined into finally selects households like that. Okay, so what the lesson that we have to get out of this is actually whenever you select a sample to get an estimate or make a prediction, use random sampling method, one random sampling method or combination of that. The main advantage of that is actually we can get an estimate, of course, but the other thing is we can say something about the accuracy of the result. That means we can measure the accuracy. In the non-random sampling method, that is not possible. Right. Whenever the other thing is that in non-random sampling methods, usually it's possible to have a very big bias. Unfortunately, bias is very difficult to calculate how much is the bias. So that's a big problem in non-random sampling method also. So if you use a random sampling method, whatever the estimate, estimate can be maybe you are estimating a population mean, or you may be estimating a population proportion, or you may be estimating a population percentage. So that quantity is estimated using a sample quantity. So therefore, the sample estimate, right, for example, percentage in the sample will be equal to the percentage in the population plus or minus some other value, right? So that's plus or minus value is called the chance error, right? So that happens usually in a random sampling method. Usually there is no bias, right? But if you are using a non-random sampling method, in addition to that, there can be a bias as well. So percentage sample, percentage in sample, or the mean, for example, mean, or the proportion, sample proportion will be equal to the corresponding population quantity plus bias plus the chance error, right? So when the bias is there, it's not possible to get estimate for bias also. And if you are using a non-random sampling method, it's not possible to measure the chance error also. Right? So that is why we always say use a random sampling method whenever possible. So in the next section, we will talk about how to measure the chance error, assuming that you have used a random sampling method. How to use a random chance error? Actually, we are discussing only the simple random sampling method. Estimating chance error in other methods are a little bit more complex. So in this book, they have just mentioned how to get the measure the chance error if you are using a simple random sampling method. Right? So we will discuss that in the next section after a small break.